My dear lovely viewers, you're welcome to my class today. So, under the gas laws as promised, today we shall be looking at Boyle's law. This is a very simple topic and interesting. There's nothing difficult about it. There are just three things you need to know basically under this topic. You should know the value, what we mean by P, V, and C. Basically, the gas laws um, is about the pressure, the relationship between pressure, volume, and temperature of gases. So let's begin with Boyle's law. The name Boyles, yeah, do not get confused. It's a name. Boyles, just as my name is Aisha, the scientist who studied the relationship between pressure and volume of gases is Boyles. That's why it is called Boyle's law. In 1622, a scientist named Boyles Dalton was the one who studied the relationship between the volume and pressure of gases. So let's test the law. Boyle's law simply states that the volume of a given mass of a gas is inversely proportional to the pressure provided that the temperature remains constant. Under this, what I just stated now, you heard me said pressure, you heard me said volume, and you also heard me said temperature. So let's write out Boyle's law mathematically. It states that the volume of a given mass of a gas is inversely proportional to the pressure, provided that what? Temperature is equals to what? Constant. So mathematically, this is the same as saying that let's introduce the constant the sign of constant of proportionality. So this is same as saying that V is equals to K over P. Then we have that K, when we cross multiply, this gives us that K is equals to PV. So this means that P1 V1 is equal to P2 V2. You have to, once you know this relationship, any question given under Boyle's law, you just use this relationship to find to find any of the unknown given in the question. It's just as simple as that. Okay, so this is the relationship for Boyle's law. Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure, provided the temperature is constant. So as I promised, after stating each of the law, we solve example, right? So we have one example here to solve on the board. So let's read out and bring out the parameters. The question says 375 centimeter cube of a gas has a pressure of 770 millimeter mercury. Find its volume if the pressure is reduced to 750 millimeters mercury. So let's solve and first bringing out the parameters. We have the V1, that's the volume, is equals to 375 centimeter cube, and the pressure P1 is equals to 770 millimeter mercury. Find its volume. So we have to find V2. V2 is the unknown in this question. If the pressure is reduced to, that is P2 is equal to 750 millimeter mercury. So now let's write the relationship for Boyle's law, which is P1V1 is equal to P2V2. So all we need to do is to make V2 the subject of formula since it's the unknown here. So to make V2 the subject of formula, all we need to do is divide both sides by P2. So here P2 cancels P2, we are left with V2 is equals to P1V1 all over P2. So from here we can substitute in the figures given and get the final answer. So here we have P1. P1 here is 770 times V1, which is 375 all over the value for P2, which is 750. So when we punch our calculator, the final answer we have when we multiply 770 times 375, the answer gotten divided by 750 gives us V2 is equals to 385. And we know that the SI unit for volume is in centimeter cube. So the volume V2, the volume when the pressure is reduced to 750 millimeter mercury is 385 centimeter cube. So, my lovely viewers, hope you've learned something today on the boys' law. See you in our next class as we move to the next law. God bless you and bye for now.